Welcome to Unit 2, Lesson 1. Remember that every time you see a piece of notebook paper on one of these videos, you want to be having your interactive notebook open because you're going to need to take some notes. The first notes that we'll take are just to update our table of contents. Let's get the ones in red on Unit 2 title page, Unit 2 vocabulary, converting numbers on page 29, which we'll do in class, and then page 31, which we're going to do today, exponents and scientific notation. First, we're going to do the exponent exploration that is on top of page 31. This is basically just a pattern that I want you to fill in so that you understand what exponents mean. Remember from your vocabulary that exponents means you multiply the base times itself the number of times specified by the exponent. So for example, 10 to the second is 10 multiplied by itself 2 times, which is 100. 10 to the third is 10 multiplied by itself 3 times. That's going to be 1,000. So what would 10 to the fourth be? 10 to the fourth would simply be 10 multiplied by itself 4 times. Negative exponents mean you multiply it by itself, but before you do it, you put it underneath the number 1 in a fraction. So it becomes the reciprocal. So 10 to the negative second is 1 over 10 times 10. 10 to the negative third is 1 over 10 times 10 times 10, and that's 1 over 1,000. And 10 to the negative fourth is simply 1 over 10 times 10 times 10 times 10. 1 over 10 multiplied by itself 4 times. Go ahead and fill in the rest of the chart, then move on to the next part of the video. Okay? Keep in mind that when you do this, this is going to work the same for any number, not just 10 as a base, but any number. So for example, let's take 5. 5 to the third power is going to look very similar to 10 to the third power. 10 to the third power is 10 times 10 times 10. 5 to the third power is 5 times 5 times 5, or 125. Let's do 4 to the negative second. That's going to look just like 10 to the negative second. 1 over 10 times 10, except 4 to the negative second is going to be 1 over 4 times 4, which is 1 over 16. Let's go ahead now and do the bottom of page 31. Bottom of page 31 is rules for scientific notation. Very simple rules, and you want to understand that the first thing we're going to be concerned with is the number in front. So instead of calling it the number in front, I'm going to call it TNIF, the number in front. And our first rule is the number in front has to be greater than or equal to 1. So 1 has to be less than or equal to the number in front, and it has to be less than 10. So it could be 1, it could be 1.5, it could be 9.9, but it can't be 0.9, and it can't be 10.1. Second rule, the number in front has to be multiplied by 10 to a power. Okay? Could be any power, and the power is going to depend on how big the number is, because the purpose of scientific notation is to help us write really small numbers and really large numbers. The exponent, okay, will depend on the number of spaces that you moved. The absolute value of x, meaning without the negative or positive sign, is going to be equal to the number of spaces you moved when you start in standard notation. You have to start as a decimal, okay? And whatever number of spaces you move, the decimal point, to get the number in front to be greater than 1 or less than 10, that's going to be x. The last question is going to be, is it positive or negative? And that depends. If it's a big number, by which I mean bigger than 10, it's going to be positive. If it's a small number, it's going to be negative. And if you didn't move the decimal at all, it's going to be 0. Pause this, make sure you've taken all the notes, make sure it's in class by Friday.